Guys, welcome back to another problem solving tutorial, and in this tutorial I'm going to be showing you guys how we can complete Leetcode question 150 reverse Polish notation. Okay, so this question is basically asking us, if you don't know what reverse Polish notation is, they do provide a link to the Wikipedia article, and it's basically another way of expressing arithmetic calculations. So instead of writing 3 plus 4 in reverse Polish notation, you'd be writing 3, 4 plus. So that's basically what it is, and the reason they do this is so it avoids things like having to use order of operations, things like that, and it just makes it a lot easier. So I'm pretty sure this was used in the old days in calculators so that the calculators didn't have to do as much processing. So anyways, the question is asking us to take in an input of reverse Polish notation and just evaluate it. So I'm going to be showing you guys how we can solve this using a stack, which is pretty simple, but I'm going to show you guys how we get there in the first place. So I'm just going to take one of these inputs and we're just going to execute it by hand just to see what's going on. So basically what this string is saying is, you can see we've got a 2, 1 plus. So first off, we've got a 2 plus 1 in a bracket, and then if we just replace that, so we know that's equal to 3. So now let's say we've evaluated that. Now we want to replace all this with 3. So I'm going to put a 3 in. We also have a 3 and then a times. And now you can see we have 3 times 3. So now we just have 3 times 3, and this is equal to 9. So again, replace all this with just a 9. So already you should start to be able to see that the way we can go about solving this is we basically have to find an operator and then two numbers behind it, and we just apply this operator to these two numbers. So here we have a triple of 2 numbers and an operator, 2 plus 1, just replace that entire block with 3. Now I have another triple, 3 times 3, and this is 9, and we're just going to repeat that until the length is 1. Okay, so there we go. We can see how this is working, and of course we go left to right. Let's do a slightly more challenging example. So let's take the second one. We're just going to go from left to right until we get an operator, which is this triple 13 5 divide. So it's going to be 13 divided by 5, and if we read this rule over here, the division between two integers always truncates towards 0. So what that means is 13 divided by 5 is going to be 2.6, right? But since it truncates towards 0, this is just going to go to 2. If we were doing 13 divided by minus 5, that would be minus 2.6, and since this truncates towards 0, this is going to go to minus 2. So we're basically just getting rid of this decimal part, like that. Okay. So now let's just evaluate this. We know that this entire block is going to go to 2, and now we have another triple when we find this, and 4 plus 2, well, that's going to go to 6. So that's how they end up with this answer, 6. Now I'll do the final example, which is slightly more complicated, and then from there we should be able to see a sort of pattern which we can implement into code. So what you've noticed is we're looking for these triples, and once we've found a triple, we just evaluate it like so. So that was 9 plus 3, it's going to become 12. Then we carry on looking till we hit another triple, 12 times minus 11, that becomes minus 132. Carry on looking until we hit this, which is a divide, and then now it's going to be 6 divided by 0, 132, sorry, 6 divided by negative 132, which is probably just going to truncate to 0. Let me check. Yeah, so it's just going to become 0. Now 10 times 0, that is simply 0, and we have this 0 plus 17, which is 17, and finally we have 17. Finally we have 17 plus 5, which is 22. So that's how we get there. Now what you notice is that we're always looking for this triple. So what if, when we loop through these, as we loop through these, once we hit an operator, we simply execute that triple straight away, add it back, and then by the time we hit the next operator, everything will be in place, right? So this is where the stack comes in. If we load all of these into the stack as we loop through, then we'll be putting like 10, then we'll put 10 and 6, then 9, and then we'll keep adding until we get to this operator. We'll pop the first 2 and then put the result on the stack and just carry on, and eventually, since it has to be a valid expression, it will eventually come down to one number, which is the answer. So that's the basic idea. We're going to express it in code now. First of all, we're going to need our stack, which is just going to be a list of numbers like so, and we're simply looping through the tokens. So we need to check whether token is a operator. So I just say for now we'll just do we can just do something like if token is operator. Of course we'll make that proper later, but if it's not an operator, then we're simply just going to add onto the stack. So stack.push token, sorry, stack.push number token, since these are our strings. If it's not an operator, then it's just a number, so we're just going to put it onto the stack. And if it is an operator, then we need to take the last 2 numbers of the stack, apply the operator to them, and then just put it back on stack. So let's do that. Now for the operators, I'm going to basically create a dictionary of actually we don't need to do that. It's pretty simple. We can just create a set. We can just do operator equals new set and then just put them into here, just so we can identify when we get to an operator. So we can just do if operators.has token, then token must be an operator. So from here, let's grab the last 2 items. So we want this to be num1. If we're looking at this triple, we want this to be num1, this to be num2. So we could use something like stack.pop, but remember, stack.pop the first time is going to return this. So first we assign num2, and then we assign num1, because once this is popped, then this is the next one on top of the stack. Okay, now we can execute based on what operator it is. So this is just going to be a classic if else sort of tree. So we could use a switch case, but I think it's just easier to do it like this. So if token equals that, let's just create an answer as well. Answer is going to be equal to num1 plus num2. If token is equal to this subtract, then answer equals num1 minus num2. And since we're in TypeScript, it's going to be undefined possibly, but we can fix that using the exclamation marks. I'm not worrying about them being undefined because this has to be a valid input. And then we'll carry on doing if token equals a multiply, then answer is going to be num1 times num2. And then finally, if the token is a divide, I don't actually need this, but I'm just going to leave it for clarity. Divide is a bit more complicated because we also have to remember the truncation. So we can get our result by doing num1 divided by num2, but this is likely going to be a decimal, and since it truncates towards 0, we need to handle the before and after 0 case differently. So answer is equal to, so I should say if result is less than 0, e.g negative 1.2. We want to take this negative 1, right? Because it truncates towards 0. So we're just going to set answer. We're just going to set answer equal to math.ceiling of result, because ceiling is going to go towards 0 when it's negative, and otherwise answer is going to be floor, the classic. I'll just put this up here so it's cleaner. e.g, let's just say 6.3. Of course we want this to go to 6, so we'll just do math.floor result, like so. Okay, there we go. So we've got our result. Now the last thing left to do is simply push this onto the stack, like so. And there we go. So once we've done this, it's just going to go through all of this, transforming all of these triples into single numbers and just cutting back until it gets through the entire list, at which point there's only going to be one item left since everything's been evaluated, and the first item, the only item in the stack, is going to be the answer. So we can simply return stack 0, like so. And there we go. So I'll give you guys an example. We can just do this one. So console.log eval rpn this input, and we're expecting 22. Let's see if that's what we get. Okay, and there we go, we get 22. So just to show you this works, I'm going to paste this in, and hopefully you guys could understand my explanation. It's basically relying on the fact that this is going to have to be valid, so that it gives us, we can just cut back until all operators have been used, and then the final number at the start is going to be the answer. This is a pretty average solution, but it's good enough since it's above average. Yeah, but yeah, thanks for watching, and I'll see you guys in a future tutorial. Bye.